Okay, before we look at this exercise, let's look at some of the definition and some of the identity that we have to use. Okay, now let's look at one of the very basics, which is tangent. Theta is actually equal to sine theta over cosine theta. Okay, so this is number one you have to use. Now number two is a square over b square can be rewritten as a over b square. Okay, now if your example would be 1 over cosine square theta, this can be written as 1 square over cosine square theta. Okay, now then this can be further simplified as 1 over cosine theta square, and then 1 over cosine is actually secant theta. So from here you convert into this. Okay, so this has to be used when you try to simplify any trigonometry function. Okay, now let's see. Okay, now another one that the other one that we have to use would be the identity. Okay, the identity, that is sine square theta plus cosine square theta equal to 1. If you divide, let's say this is number 1, so number 1 you divide by sine square theta, so it's sine square theta over sine square theta plus cosine square theta over sine square theta equal to 1 over sine square theta. Okay, this one cancel, you get a 1. Okay, plus this one, how to simplify this? We will use this method here. So we can take it as cosine theta over sine theta, take out the square. Okay, then this one the same. This is 1 square over sine square theta. Okay, now going further, this cosine theta over sine theta is actually written as cotangent theta. Okay, this cosine theta over sine theta. Basically, this one, if I flip this, 1 over tangent theta is actually cosine theta over sine theta. Okay, so 1 over tangent theta is actually cotangent theta equal to cosine theta over sine theta. Okay, so similarly, this cosine over sine theta is tangent, cotangent theta, and then you put a square here. Okay, this one basically is same as this. In this case is 1 over sine theta whole thing square. 1 over sine theta is actually cosecant theta square. Okay, so this will become 1 plus cotangent theta square. This becomes the number 2 identity that you have to use. Okay, this is number 2, this is number 1. The third one, if you divide by cosine, take the first identity, divide by cosine square theta. Okay, so you have sine square theta over cosine square theta plus cosine square theta over cosine square theta equal to 1 over cosine square theta. Okay, this one cancel, you get a 1. This one, if you take out the square here, like what we do here, so you end up with sine theta over cosine theta. Okay, and that is actually tangent theta, and then you have the square here, it becomes and square theta plus 1. This one same thing, what we do here, it becomes secant square theta. Okay, now let's we will have to use this plus the 3 identity. This is the third identity to simplify this trigonometry function. Now let's start off with the first one. This one earlier in the class we have talked about it, so I will not want to repeat. But let's see what we can do about 17. Okay, 17 is actually tangent square theta plus 1 over, without the 2. So basically, cotangent is 1 over tangent theta. Now, let's combine these two into one. So let's create a denominator of tangent theta. Okay, tangent theta, this tangent theta. So this one, if I make the denominator tangent theta, so it becomes tangent theta times tangent theta in the numerator. So this becomes tangent square. Maybe I should explain it a bit more detail. Now, so let's make this tangent theta. So originally this is over 1. So if I multiply tangent theta over 1 times tangent theta, so here also times tangent theta. Okay, why we make the denominator tangent theta? Because we want to combine with this second term, 1 over tangent theta. Okay, so this is 1 over tangent theta. Okay, now, the numerator of the first term become tangent square theta. The denominator is tangent theta. So same as the second term. So with that, we can combine the numerator. So it's tangent square theta plus the 1 here over tangent theta. Now, here we're going to use the identity to simplify this further. Okay, now look at here. Tangent square theta plus 1 is equal to secant square theta. So this is actually secant square theta. Okay, now over tangent theta. Is that all? Remember, we should convert as simplified as possible. Okay, now normally the simplest form will be end up in this manner. There shouldn't be any new denominator, like for example tangent theta. Okay, so this one we will simplify further. Secant square theta is actually 1 over cosine square theta, because secant theta is actually 1 over cosine. So secant square theta is 1 over cosine square theta. Okay, then time this tangent theta. So it's actually, you have to flip it. This actually is over 1, so become 1 over tangent theta. Okay, now, but we know tangent theta come from here is actually sine theta over cosine theta. So we're going to simplify that time 1 over sine theta over cosine theta. Okay, now I'm going to flip this up. So 1 over cosine square theta times cosine. This one going to flip over sine theta. So this cosine square theta, we can this cosine theta, so it cancel. So we have 1 over cosine theta times 1 over sine theta. Okay, now 1 over cosine theta is actually secant theta. 1 over sine theta is actually cosecant theta. That's it. We have combined, first of all, we combine the two terms. When we end up this, and then we simplify further, we remove the denominator, which is tangent theta. So this will be the answer. Okay, now let's look at what about this? Okay, or we look at this one. Let's look at this. Okay, let's do it over here. Now, sine square theta plus cosine square theta, using the first identity, is actually equal to 1 in the numerator. Now, then 1 minus cosine square theta. Now, let's take the identity, the first identity again. The first identity say that sine square theta plus cosine square theta equal to 1. So, I'm going to use this identity. I'm going to move the cosine square theta to the right hand side of the cosine. So what happened is, if I do that for the first identity, I will end up square theta, sine square theta, equal to 1 minus this one, move it to the right hand side, it becomes a negative. So it becomes cosine square theta. Okay? So 1 minus cosine square theta is actually equal to sine theta. So this sine theta square. Now, let's use this again, what we have done earlier. So this is actually 1 square over sine square theta, then 1 over sine theta square. This will give you cosecant theta square. Okay, so you have simplified. So I have done 2 examples. You can have a look on this one. I want you to try this. Okay, this one I will show you now. This is simply complicated, but let's see how to do this. 1 plus tangent square theta over 1 plus secant theta. Okay, now this is slightly complicated, but still manageable. Now, tangent square theta. Okay, let's look at this. Tangent square. If I make tangent square theta the subject, then tangent square theta is equal to sine square theta minus, this bring over become minus 1. So in other words, this tangent square theta is actually equal to secant square theta minus 1. So secant square theta minus 1 over, let's rearrange this as secant theta plus 1. It's the same. Now, remember 1 can be put as 1 square. So you have the case like a square minus b square. A is actually secant theta. Then you got a square, that's a square. Then 1 is b, you have a square here. So this can be written as a plus b, a plus b, a minus b. Okay, so this can be written as secant theta plus 1 times secant square theta minus 1. Oh, sorry, Teacher miss out the 1. Okay, there's a 1 here, 1 plus. Let me write it here. Now, this can be cancelled off with this. Okay, so what remain in this case would be secant theta minus 1, which is this, plus 1. This cancel off, so this give you secant theta. That's it. Okay, so you notice that we have used this conversion and this conversion and the three identity in simplifying the trigonometry function. Okay, so you go ahead and do these 3 questions. Okay.